Hi everyone, thank you for joining us for another workshop in the Shape Rotator Hackathon. I hope you're looking forward to this one. It was introduced early last week, or late last week, I guess, and this workshop is going to be specifically on AI tooling, and we're going to have some really cool demos today. So we have lots to get through, so we will get started pretty much straight away. I'd like to welcome our first speaker. We're going through first agentic workflows in financial research, which is fun. I'm going to invite Andrew up as a panelist as well. So Andrew, if you want to say any kind of opening words, you're welcome to. Otherwise, we can jump right into the first session. Maybe not. Should we get going then? Welcome.
Hello.
How are you? Yeah. Let me share screen.
Hi, Rebecca. Hey, Raja. I've got an audio problem on my end. I'll fix it in a sec.
No worries.
Can you not hear us?
Looks like it's a hear-only audio problem.
No problem. Let me share screen, I guess.
Yeah, I'm guessing Andrew can't hear us. So
Good. Hello, I can hear you.
Oh, now you can hear us. Okay, amazing.
Awesome.
Can you all see the screen?
Yes, we can.
Yeah, we see it.
Okay. Maybe let's get started. Or
yeah, do
is
it.
there anything? Yes, for me, thank you for the invitation, Andrew, and nice seeing you again on Zoom, at least. And today we're going to talk about Agentic AI for financial research. Everything's quite preliminary, and given the fact that we're doing a workshop for hackathon, I'm just trying to, because I have to explore all kind of usage for Agentic AI for a broad range of financial research. I'll tell you what I've tried and what may work or definitely doesn't work, and what kind of things you should be emphasized when you build the agentic workflow, like what infrastructure actually matters. So I'm not going to give you like very detailed demo because a lot of the loops I use take like days to run, but I'm really just going to tell you what's going to work, what's not going to work, at least from my experience. First, a bit about myself. I'm Rachel, and I graduated from Columbia. I'm currently assistant professor at Stanford. I used to be a quant, so I do like DeFi systematic trading, market making, and some VC investment and so on. And my research is mostly on how to use technology to transform financial market. So there are something about trading, market design, blockchain, but today we're going to talk about AI for financial decisions. And let's start with what definitely not to do and what I tried that actually works pretty well, and the lessons I've learned throughout the way. I'm going to go pretty quick because the time pretty tight for 30 minutes. So there is a key insight I want you to know is the model going to evolve quite quickly in the next year, as you can see from the past 3 months, 6 months, 12 months ago. And then, but what more important, like how you work with those things, what's the infrastructure you build around that? How do you have a metric that really works well for you? So those are things you gradually see that makes a huge impact in your agentic workflow. But we won't get there quite quickly. So what definitely doesn't work, I think the temptation everyone has when they have agentic AI is just have an AI agent that trade for you. So they congest information and you just feed data into a large language model. They may not even make prediction, but they just give you a action you want to make and then execute those trades. So you can see on Twitter, people just have open claw, like look at poly market or different crypto to all kind of thing to trade for you. And I think given that it's a hackathon, I think many people may have temptation to do it. But I think the first thing you should learn is, I think that's something you should definitely not do. Why is the case? Because it just, if you look at one example, for example, if you look North One, that's a startup doing a lot of AI trading, they do experiment. You look at their Alpha Arena, and you see what happens is really if you have just agent do trade that pretty ad hoc, what's going to happen is they all blow up. And what really behind it is pretty much LLM are not trained for time series prediction, and and also financial data is extremely noisy to do any reinforced learning, and you don't have much samples. And even if you look at the Anthropic blog, they say even today they do all kind of scientific experiment, but for time series prediction is pretty much hard. And so like if you don't have a quantity framework overlay on top of that, what you essentially are doing is just coin flip. They tell you this is good, and then you make a random trade. And eventually your output, sometimes it looks good, but what really happens, you're doing coin flip, sometimes it's just lucky. And you also have transaction costs. You also have a bad risk control. And what happens eventually is going to blow up. So that's the first thing you should definitely not try, because it's pretty much a coin flip. And I've talked to alternative startups and people who are trying to do it end to end. I think the only way this is going to work is you pre-train a new model, specifically designed for the data, like financial data for prediction, do it very carefully, and have a good overlay on top of that with domain knowledge. What is good quantitative research? And so that's the only way it's going to work. So, but you shouldn't, with the capacity you have in the hackathon and so on, where for most people, it's just not going to work if you just want to have end-to-end trading. So the first thing I want to say is this is something you definitely should not try. Is to me is a dead end with most people's research. So, but then there are things people actually can do that from both academic-wise and industry-wise, right? So eventually, I think it just verification. If you have Agentic AI to verify your thesis as a financial researcher, especially some of them are quantitative method to verify things that are fundamental views. Actually, I think it's going to work pretty well with some really nice workflow and scaffolding. And second thing is, we used to have heavy labor just to collect information in the world. For example, if we have a lot of VC want to figure out, are they like really only doing VC where they're doing other things like market making or other stuff? Traditionally, you have hired tens of analysts where people just collect data for you, but information aggregation is just much easier. So those two things I'm going to emphasize a little bit, that definitely gonna work, and it just depends on what kind of infra you build, what kind of data pipeline you have, how you verify things, and those things definitely gonna work. And it's gonna transform how I do finance. And those things, I'm gonna introduce something that are still on experimental phase. It's pretty hard to, I think even today, like what is good explorative analysis? As a researcher, we go out there, just look at data, to look at market, to look at everything, to just write down equation to figure out something, and we try to connect dots. I think AI are really good at connecting dots because they just have much bigger memory than we have. But even today, expert analysis is pretty hard. And second and third thing is like optimization. I'm pretty sure if you are looking into AI, you know there's auto research. You have just agent keep optimizing some research workflow, try different parameter, try different things to optimizing existing research workflow to generate insight. But I'll tell you that's actually not as simple as it seems. You can just bounce around and get nothing, optimization, get stuck somewhere. So those are two things that are still like, I think the whole world is trying to figure out how to do it. I think like there is a lot of value to be spend time on doing that. And a lot of things like theory exploration, like as academic, we definitely need to do a lot of theory, because theory derive, like basically theory express our views, theory help us to do formal mathematical derivation, make sure that what we want to say is mathematically proved. And I think theory exploration, theory verification has gone through a revolution. Eventually, maybe in the future, most of the mathematical proof will be verified by AI. The journal doesn't have to hire like 10 referees to look at the correctness of proof. We currently today is very hard to verify, especially for social science. People still want to focus on big picture. But in the future, I think theory exploration, theory verification is going to change a lot. So those are things I'm going to quickly go through, and eventually I'm going to introduce another fun fact I'm using AI for my research. And like those are just big kind of image, big idea, but I'll try to go a little bit deeper, but eventually you still feel like it's sometimes a little bit intuitive. So the first thing, right, how traditionally people do discretionary trading, this is more empirical, more like industry driven, right? People have views. People have thinking about if this thing happens, that thing happens. They think about like, they bet on maybe like how the geopolitical going to change if this thing happens. And they bet on like, if this happens on news, this is what's going to happen in the polymer and so on, right? People have views. And traditionally, like you have people who have views, and you have people who are verifying those views. You have really good quant, you have systems to quickly transfer views into a trade and to verify if they're going to work in the future, in the past. And that's traditionally requires specialized engineer, quant people to have data source, and takes some time to build a framework. And each time when you want to verify the view, probably take a week or a few days, right? If you want to try, if this thing happens in the to NVIDIA, what's going to happen into the equity markets, closed market auction, then you have to collect data of all the closed market auctions, assume that you already have a data pipeline. You have to think of what is correct in terms of quantitative research, and you want to verify them more scientifically, and you have to connect to different people, like quant have to talk to traders and so on. And I think AI, it's just going to solve this thing quite quickly. It just takes days or hours to do those verification very easily. I'm just going to give you an example. It's just something I spin up very quickly. It's not something it's definitely not a financial device. Definitely not something I think will make money or something, but it's just something to give you a thought on what can happen. So people we're all in crypto, we know that we have all the tokens. But when you can see a lot of projects, their only products tokens, and they get listed on exchange like Binance, OKX, Coinbase, other exchanges. And you realize that everyone just needs to sell those tokens. They need to exit. And then you may have a fifth that whenever, I think there's a Twitter tweet that just show how the token price drops when they're launched on Binance. And eventually it's not surprising that if token is the only product, when you're launched on some exchanges, everything's going to go zero, right? But the question is, how do you verify that? You have to collect all the data, you have to verify things, do back testing. And for someone you just don't have time, it's just not going to happen. But now, if you have really good quant overlay, you have with good research, you can let agent build that very quickly. So that's just something I do. You have hypothesis, which is all tokens can go down a lot after get listed on maybe Binance or some other exchanges. You have data pipeline collecting those data. You know what is proper back testing, and to transform your views into different strategy and their parameters. And you have scientific gate to make sure what you're doing is scientific, and eventually have insight, right? So for example, first you have proper data pipeline, but now AI can do it very quickly. They can just connect your workstation with data source very easily. And then you need proper tools, right? You need them to build a code to whenever you have a logic, what's going to happen, what's going to be the trade outcome like. And you also have the scientific gate to make sure you have proper, you don't have look forward, you make sure you don't overfit, you have proper trend test splits and so on. But those things are really easy to build. You just have to have some person code something very carefully, prompt carefully, and everything happen later, you just have to run this pipeline. So for example, you just have a lot of coins. I just talk to the GPT Codex Cloud Code on what the pipeline like, and do it a little bit carefully. Then you can see oh, I want to see, sure, things going to drop. First, do you make money overall? Yes, you do make money just by shorting coins, if that are listed on Binance. And then maybe then you think about strategy, right? Should I, if the coins drop 50%, should I take a profit or something like that, right? Then you can see different parameter, how if you take profits, typically better, right? So you can just do parameters change very quickly to figure out what are different implications for different strategy and get insight of it. The experiment speed just go much faster. And then eventually, for every agent workflow, you need a quality control. You need for example, in quantitative work, you have to know what is a good quantitative work. You definitely should look ahead. You definitely need proper scientific gates. You also don't want to just run backtest. You need properly first build the tools and then run it. And without a really good quantitative gate, it's just not going to work. So that's just the first use case, right? And second thing, right, information aggregation. Currently, I'm doing a project which I work in the finance world. One big thing that finance most projects venture capitals, right? But you realize that for the venture capital, some are just pure venture capital. They bet on who's going to be the next Uber, who's going to be the next Ethereum, Solana, and then some are also doing other things like market making, OTC, liquid fund. Then you want to have a data source to say, if a VC is backing a token that runs a market making, are they going to sell it quicker than other people, and which gonna maybe make the token perform worse and so on. So like then you can study the mechanism. Does it really make sense for VC to allow to do all the things in addition to venture capital investment? How do we design the market, make sure we properly finance real contribution to the world? So, but this is very tricky, right? I have a data set of 100,000 VCs, and like I can't hire enough people to just like label data to say who not only have a VC but also have a liquid fund in Cayman, who also like do like trading, who also do OTC deals. Even for public data, and I send people to just go Google and search it, it just take forever. But AI just makes such things way easier for information aggregation. And then so basically what's happened, like you can easily ask AI to do all the things and ask AI to verify things. And then eventually you're going to have a data set that just do exactly what I said. So what does it look like? So eventually I'm going to have some VCs, right? Initially, like I just know what VC they are, what project they invest. And then I'm going to have agent gradually just aggregate information online to have verified source of, are they have a liquid fund? Do they also do market making from public data? Do they have same to do OTC trade from all the data sources we have? Do they have entity location elsewhere by looking at public filings? Like do they have, so eventually, if I have an agent pipeline, some fund information, some verify them, some do cross-reference, and eventually I'm going to have like a data source that takes 10 hours to build, a quarter to build in the past, and I can actually like just have this data source run the first order question I think is important. So you can see like if you have an agentic workflow, it's really just minimize the cost to aggregate information from the data source you already own. And you just have to make sure you have the proper agent flow to find information, verify that, cross-reference. So those are a second thing that you can do. But I'll go more in detail how to properly build such a thing. But I think I want to tell two more angles that are just hard nowadays to figure out what is like how to explore analysis. So one thing I realized that's like you have all the data source. Like I have on-chain data, I have like those VC data, I have all the trading data. I imagine like if I'm a human, it's hard to connect all the dots. But I sometimes think with AI I can do it. But it's just much harder than you think. So currently a lot of work is still like human just know what are different things AI should look at, and they send AI to do the job. But there's still a lot of human involved there. It just seems to me if you like them to do open exploring without much essential guidance, it's just garbage in, garbage out. So even connecting the dots, like which seems natural, is not that natural in terms of exploring analysis. So if you're building something in the hackathon, if you can find something just connecting dots, that's actually like pretty valuable from what I think. It's just we're not there yet. Also optimization, right? If you're on Twitter or if you following the like agentic offlow, so my friend George, we're going to talk more about his workflow. He tell me, oh, you can see this auto research, and I look into that. So basically, you can see like what they do is very simple. They have some AI that constantly run experiments, and they evaluate on a benchmark, and then decide what works, what doesn't work. And then eventually you can see that AI just does a perfect job on gradually optimization things overnight, achieve a better and better outcome. So that's something like if you go to GitHub, look at auto research for empirical work, that's actually like happening pretty well. But then if you look at detailedly like to how research really works in reality, I mean, it's not that simple, right? This is something like is a labor work. You do experiments, you optimize things, but like in reality, it's pretty hard. Like you don't typically what you want to optimize, what's the correct benchmark? It's actually quite hard. Like financial data, especially, is very noisy. Like if you just look at returns, you can learn a bunch of noise and overfit, right? And also like you want clean environment. Like you want just few parameters you can tune around. But like in it's unclear to most people what are the right knob you want to tune. Even you want to optimize hyperparameters. Sure, in the model you have all this parameter, temperature, and so on. But in other broader framework of research, finding the right knob is actually already hard enough. You need enough taste to figure out what's the right knob. And also like, so eventually you think like you need right judgment to figure out what kind of knob you want to tune, what benchmark you want to optimize. So this is actually quite hard. I think we're just getting started. You can see like in the future, people are going to have more and more auto research. The issue is most things going to produce garbage because you don't have the right benchmark. You also don't have, which is really essential to like agent try the right reward functions. And also like, they probably don't even know what knob to tune and where to look at things. So like this negative thing I think is just happening, but it's harder than it looks like. And if you can build something out of it, it's super valuable for people. And one thing, like when I talked to Andrew, like when we met 2 weeks ago, like he got very interested like theory exploration. Social science, especially, is not the pure maths has went through such a long way, use linear language or so on to formalize proof and verify that. But social science sometimes is, you can see people do things like not that rigorous. They have a game theory model, but a lot of time when you describe model, we don't do a formal tree structure. You actually just describe with words. And humans actually don't force themselves to explicitly state every single assumption very clearly. And modeling become an art. Like eventually you can see some models just more elegant, capture the reality, and produce results that make sense. Some just doesn't. So a good researcher just master that art way better. And eventually you have some models who are really useful, who are really beautiful, and that heavily decide on human judgment. So it's not like a pipeline. You can create 20 models and see what is good. So basically, like now, like with AI, with proper mechanism, you can just, instead of just proving in one direction, you can explore multiple model variants simultaneously, like in picking the one that you sense most has the most like promising direction. You don't have to hire RAs to explore things. You just can just like AI do 15 directions. All you need to have is a big, really good taste. What is elegant? What is good? What is matching with realities? So how do I do that? So I have a research project thinking about if Ethereum goes from 12-second block to sub-second, and what's going to happen in like AMMs, liquidity provisions, and what are the optimal strategies. I have a lot of data to know what is reality. I also know what results are true from my really ugly model. But the issue is there's so many ways to model that. I firmly believe there's something just way more elegant. I just don't have time to maybe optimize to the most elegant model that everyone just read the model and be fine with that. But now I have something to start with, but I can just pick 8 variants to tweak my model and see things simultaneously. I not only can see how robust my model is, I can explore maybe there's just more elegant directions. So eventually one will shift from like execution to judgment, like what is good models and what kind of things valuable direction to explore. So what happens is I have the framework, which is like if you look at AlphaEvolve or those like math proof works, pretty similar, but for like social science, you're like pinning down assumptions really hard in the sense of there are assumptions that are really implicit, like speed cannot be negative or and so on. And then eventually you write down your first proof and decide different variant you want to go all different directions. And you have a different loops to check your proof and to audit them. If they figure there's something wrong, you have to fix it. And eventually loop until everything converge and humans start to check proof themselves and pick the winners. So the first step is always pin down assumption, which is hard. And the second thing, why do you need the audit loops? And why do you need some simultaneous audit to guard against false positive? Because LM, like even you ask them to audit math, they can make mistakes. You have to have like 4 or 5 of them. Even today, the model is getting better and better. Well, after it reaches a certain threshold, you just have enough of them to audit. You actually have a pretty good picture of that. And eventually, for anything you want to seriously notice, I think human checking is still quite relevant and still a must in the end. So that's the framework I use, and you can see like sometimes I just have 8 different models, like agent run like 2 weeks of like fix my theory, audit my theory. I think it's going to change from like how I do theoretical work from now on. But you can see like they do this, they realize very subtle issue, like they realize I'm probably not linear and it's not divergent, and the whole thing just breaks down, right? And then they fix it. So like they just do like things that are quite amazing. They realize there's a mistake as equivalently in 96 steps that are actually wrong. So there are just things like they capture pretty good. So, but then you should realize that this is sometimes just doesn't work. You can observe your agent just stuck in the workflow, just bounce around, they fix things, seems to make things better, but they break other things. So you can see that like sometimes if your model you don't have a test to go into the right direction, plus you don't have specify all the assumption clearly, and there's humans not always in the loop to optimize things, you realize the loop can break very quickly, can never converge. And that's something when you do anything like auto research with the loop, you have to be very careful about. So non-converge can be an issue. Then you have to start over again, have a different starting point, so you can get stuck quite easily. And what really happens is, even today, like raw is getting better and better, but where taste comes in is like, what are the convergence gate rule? What do you think is good enough, and how do you validate them? And eventually, how do you have structured iteration, and that's give to the good outcome? So that's something like you should think about. What is good? What is done before you even start, and how do you verify them? So those are things that are just typical on any agent workflow. You have to think very, very carefully before you even start. You have to think about what's your success, like for your agent to converge, what should be rejected, and how do you verify that? And eventually, like you still want to build infra. Like for me, I spend a lot of time building infra for like everything I do, how quickly can run experiment. If something you have to run like 5 months, probably it's not worth the time. I should just first improve time to build infra, no matter it's data work or just theory work, right? Second thing is experiment level. Like, how can I make sure I don't get stuck? How can I make sure each iteration, my thing's getting better and better? And eventually, like, I need to make sure that the direction is right in the first place. If it's not right, and make sure the gate convergence rule is right in the first place. If those not right, those two things don't matter. So the judgments do matter a lot, even today. So if you're building this week, maybe you can try, there's some idea, right? You can have a business intelligence agent, token launch audit, protocol risk, given that I saw DeFi is part of the things you can build in this hackathon. And key takeaway is like, first, something you shouldn't do is just build an AI training agent and pure prediction, and then it's not going to work. It's dead end to me, unless you're like Hudson River Trading, going to pre-train a new model from start. Do you use agent to verification, aggregation, exploration, and optimization? And those things are really valuable direction to try. And do invest a lot in scaffold infrastructure. Be very explicit. What's our really good convergence rule? How do you verify them? And recognize what is a dead end early, because you need, I think, like gradually evolve yourself with the AI system to figure out what's a good test. It's quite important. And you realize the future model can get better and better, and your taste, your convergence rule, and everything, I think is at least in the next few months going to be your moat. And one interesting I experienced in my lab is like, if you ever do a PhD, you realize have a PhD advisor pushing you always is very annoying. But on the other hand, I realize if nobody is monitoring what I'm doing, maybe like, or give me a nudge, it's not very effective. So one experiment I'm trying to do is just have an AI system to nudge myself and potentially my PhD student to have a really high-level views on what you have been doing, are we blocking each other, and so on. So I'm part of the system to be nudged by the AI. So I'm just experimenting AI as project manager to track all my progress, remind myself of my deadline, to flag where I get stuck, and they can be brutal. But the issue is, I think it's going to work pretty well, and I think turn out people are much more willing to accept accountability nudge from a machine than from a person. So that's something like, it's just a fun fact I'm experimenting. Eventually, like, thank you so much for listening to all the like high-level description of things I've been trying, and hopefully it's helpful to you. And if you want to contact me, just that's my information. Thank you so much.
Thank you so much for coming and delivering that session. We do actually have someone in the crowd with a hand up, but Ivan, if you'd be happy to, would you if you have a question, could you put it in chat? I hope that's your thumbs up. They're anonymous, because we need to move straight on to our second session, because that first talk was perfectly timed. So thank you so much for coming and delivering. Next up, we have a talk on Smithers and JJ Hub, a React-based agent harness and coordination with CI/CD. Very efficient. Thank you we can see your screen. That's looking all good. If you are going to be doing quite a lot in the terminal, could you zoom in a couple of times, because it is quite small?
Absolutely.
Let's see. Is this a little bit better?
Yeah, that's better. If it should look a little bit strange to you, but it looks good to us.
Awesome. Okay, so basically, what I was hoping I can do is just see like how much of my last year of like doing a lot of vibe coding and learning a lot of lessons, like how much of that knowledge can I like transfer to you in 30 minutes? And I think the fastest way to do this was I first just like talked to ChatGPT and I just said like, hey, here's like everything I know dumped out in like not very organized way. Like give me a list of lessons I can teach people. So we're gonna go through these. I haven't read these yet. We're gonna go through these and basically see if I can like explain these and if I can possibly like do like a live example of what I mean so it doesn't sound overly too theoretical. So on the right side is my lessons. I'm gonna go ahead and close this and then pull this up on a different screen just so y'all have more room to see anything I'm working on. And then let's pull a tab out. And then can you see me? Can you still see the terminal that typed? Can you?
Yeah, right, yeah, we can just see the terminal.
All right, perfect. All right. Do AI tools. All right. So the first lesson, and I think this is like possibly the most important one, is this idea, and it was talked about a little bit in the previous one too, actually, the previous talk, is this idea of thinking about how you're going to get work done with the LLM is really about getting like validation points. So here's like one thing, here's like a mistake. Here's like a very clear mistake you can make. So like, let's say I'm building a TikTok game, which I did in this repo. So I'm building like a TikTok game and I want it to be just like two AIs building tic-tac-toe. So a mistake I could make here is I could say, we are building a tic-tac-toe game. I want you to get started building this by building the API. So does anyone have like a guess on what I'm doing wrong here?
Hey, did you send that to a different tab? I still only see the Claude Code tab with /clear.
Let's see. Is it not updating? You see /clear, but you don't see we are building a tic-tac-toe game.
Yeah, exactly.
Here, let me do a new share. That will probably fix it. Window. All right, now can you see any text?
Yeah, that's better. Thanks.
All right, do you see typing?
Yeah, I see the typing now.
All right, cool. All right, does anyone have a guess on what I'm doing wrong here? Like why would this be like a bad first step? There's actually multiple reasons this is a bad first step, but so just like call out anything you think I'm doing wrong here.
I mean, it's so general, that could be in any environment.
Well, the owner has said that you're trying to build right away.
Yeah.
Guest,
yeah,
who I don't know who that is, has said you've done no planning.
Yeah, that's it. That's a really good one. Yeah, no planning. Any guesses on why? Because I'm gonna go like pretty theoretical on why plan mode is important. But like, does anyone have like any like intuition on why plan mode is so important? So it's basically comes down to context engineering. So this is actually really important. So I'm gonna just jump into nodes.txt. So there's only like 3 ways to actually like that we have power to get better performance out of the LLM. That's 1, we can provide sufficient context. 2, we can like not provide bad context or wrong context. And then 3, we cannot provide noisy context or useless context. So like pretty much all of this idea of context engineering is just like all comes down to these 3 ideas. And I guess there's like a 4th idea, which I would call hill climbing, that maybe we'll get to later. The reason why plan mode is so important is because planning is just like inherently messy. Like I don't know what I want yet. Like, you know what I mean? Like when I'm saying this, like I think anyone who's ever worked with as like a contractor knows this is like a normal thing where like your job as a contractor isn't to build what the person asked you to build, is to figure out what they actually want, because nobody actually knows what they want. I don't actually know what I want here. So like this idea of like coming up with a plan is going to be inherently messy. So like when we come up with a plan, what's going to happen is we're going to like go down wrong path, pull in docs and stuff that aren't relevant, HTML sites that aren't context efficient. So like what a plan actually is a plan is this it's almost like a compression of our research. So we do like research, we think about like what we want, we go back and forth with the LLM, and that's basically, and then compress that into a plan. And the point of that compression step is to get us to a point where we have like all the context we need. So we satisfied number 1, and then we want to get rid of like all this stuff that's in number 3, and there might be stuff in number 2. Like for example, if it turned out what we thought we wanted after like digging into the plan wasn't what we wanted. So we can go a step further. So I'm going to like jump ahead, I guess. And I think like Claude Code, one thing Claude Code does badly here is there should be another step before plan mode. And I think most like pretty advanced like context engineers I know do have another step. And I like to call it research plan implement. So before plan mode, I think what would be better here would be to actually like have a research step. So what I would do here is I would say, let's research OpenTUI. I want you to find any documentation you can find on OpenTUI. Let's pretend tic-tac-toe is not like a game I don't know very well. Can you like find the rules of tic-tac-toe? I don't know how tic-tac-toe works. Can you explain to me how tic-tac-toe works? Can you look up Smithers? We want to use Smithers as the AI to build this. Can you look up documentation on that? What else can you use? Can you come up with a list of 10 questions for me? So we're going to be building a tic-tac-toe game with Smithers. I want you to ask me 10 questions that you think will get you the context you need to be able to get this done. I would normally like keep going beyond that. But like this is like a good first step, is basically like you kick off the LLM into like and I think of this as like a context gathering step. This is like the most messy part. This is the part where it's going to be like web searching and stuff. And basically what I want here, like the reason why I'm adding this extra step is because this is almost like planning the plan. Basically like research means do messy step of finding useful context so that we have clean context to plan with. So like instead of just like having this huge messy like research plus plan step, like I think what a lot of people like to do is they like to basically like plan the plan. It's like, I want you to research and then get all the stuff that we need to come up with a plan, and then we'll have like a fresh context window, and use that fresh context window to actually come up with the plan. So the next thing I want to talk about, actually, before I go on, is there anything like, let me look at the questions. Research is basically obtaining context, and then, yeah, research is like casting a wide net. It's like, if we were like in a bigger, like if we went to my JJ Hub repo, for example, which is like a production app that has like a lot of code written already, like part of that research would be like find all the relevant tests, find all the relevant source code, find any like commits in the past, find any documentation in our documentation or our specs that's relevant. So it's like casting this really wide net with the goal of making sure that by the time we get to later steps, that A, we have correct information, and then B, we have all the information we need. We won't have to like look at more docs or look at more, do anything that's like not context efficient to like pull in more information is kind of what we're trying to do. And yeah, definitely, I think like a thing that I've been doing consistently, I think a lot of people do, is I really like spend a lot of investment in that docs folder. I like to create a doc for most things. It depends on the project, but for most things, I like to create like a product doc and an engineering doc is like two separate docs, and I like to try to keep those in sync the entire time. So I think of the docs as being North Stars. It might not represent like where we're at now, but by creating those like North Stars, it's like it becomes like really easy context you can give to the LLM that will like help steer it in the right direction, because it kind of knows like what you're building towards. Plans are useless. Planning is invaluable. Absolutely. Building right away, no planning. Okay. Let's see. So the second lesson it says I should talk about is optimizing for one-shot ability. I think we'll get to that probably later. Yeah, it came back with like a good question. So like a lot, depending on like how important or how complex the thing is, like this kind of like asking the LLM to pull context out of you. In the past, LLMs were pretty bad at this, actually, like a year ago, but LLMs right now are really good at this. So I think there's like, it's really easy to actually underinvest in this step right here. I think for a lot of projects I've been building recently, and I think like I'll spend like up to like an hour just talking back and forth with the LLM at this stage. The fourth lesson though, I think so. The fourth lesson I think is relevant for like where we're at right now. And the fourth lesson is to use real back pressure. So I'm gonna like say, just so we can move on really quick, I'll say like use your best judgment, and then I will instruct further. All right, so the next step, the next lesson, this is like a very important one. I think this is really what, if there's like one thing to take from what I'm going to tell you today, it's this. It's that like back pressure is everything. So what is back pressure? Let's write it in notes. So back pressure is anything that slows the LLM down for the sake of higher quality output. So that's kind of theoretical. An example, the easiest example is tests. So test is just this like automatic thing that can run, that can tell your LLM it's doing the wrong thing and force LLM to fix stuff. Reviews. human or LLM. So interesting thing about reviews, like you're almost certainly underutilizing the LLM reviewing itself. So when it comes to humans, I get really offended if someone asks me to review their PR and they clearly haven't reviewed it themselves. And LLMs are no different. And the thing that you might be surprised is that if you have the LLM in a fresh context window review its own code and then basically do a loop until it's like, it looks good to me. In my experience, it takes on average like 4 to 9 loops before it actually hits a looks good to me. And that sounds like shocking. You would expect it to take 1 loop or 0 loops because it's like reviewing its own code. But it's like very much not rare for it to go 9 times in a row, finding issues, finding bugs, finding ways to improve the code. So an LLM reviewing itself is a really good form of backpressure. But then I think there's this question of like, what is a good test? So if I went back to that prompt I gave earlier, there's like another thing that's wrong with it. Oh, where'd it go? Anyway, so the prompt I gave earlier, another thing that was wrong with it was that I told it to like build the API. And the API is like it's like only like part of a feature. And what I mean by that is like, we're trying to build a tic-tac-toe game. If the LLM builds this API and writes some tests, is my confidence is I only have confidence that the LLM passed its own tests. I don't know whether those tests are testing the right thing. I don't know whether they're like anchored in like I don't know whether it will work once it's connected to the UI. So like a prompt you would rather do in this situation is like, can you build the like board feature? I want to be able to see the grid and see tic-tac-toe, or see what are they called? O's and X's, O's and X on the board. So this is like slightly better. The problem with this one is this is going to require me to manually verify it. So what would be better would be this. This is actually the prompt we should be doing. I probably should have done. This would probably happen in the research phase. I will say, we are building a TUI, but we need to be able to end-to-end test it. I do not know how to end-to-end test a TUI. Can you web search and find open source playwright like end-to-end testing framework we can use? So I think the best engineers will like, and this isn't like an original take from me. I wish I could remember the name of the first person I heard say this, but like the best kind of vibe coders, prompt engineers will spend like most of their time on backpressure. And I do this too. Like I spend most of my time thinking about like, how can I get the LLM to produce like artifacts, like in the form of like passing tests that just give me like overwhelming confidence that it actually nailed this feature. And I think if you think back to like your own experience working with LLMs, you'll like see why that addresses like the number one biggest bottleneck, right? Is like, it's really hard to trust these things. It's really hard to like review these things. It's really like it's very like it produces code faster than you can read it. And it's really easy for it to like kind of trick you into thinking something works, and then you find out later it just like mocks some stuff. Like there's like a lot of things that can go wrong. And if you can kind of like create this level of back pressure such that you just have this like overwhelming confidence that it did what you wanted it to do, how much better the LLM will produce work and how much faster you'll be able to like work with it will just go like through the roof. Let me read the chat really quick again. I saw some blogs mention that if you can provide good reference code, it can have agents find the style and trick to do. Yeah, that's a really good point. I think like, yeah, when you start a greenfield project, it's like one trick to do here is like, let's say you're starting a greenfield project and you're going to use effect.ts, for example, you might, or let's say you're trying to, or another example, let's say you're trying to build like a Swift project with like Swift and Zig. This is a real example. So I have a project I was building that was like a Swift UI with like a Zig backend. So the first thing I thought of was like, okay, I don't want to like greenfield this. I want to like think like who has a code base that has like good styles and good like things I can tell the LLM to emulate. So I picked Ghosty, or like if you were picking effect.ts, you can like pick like the effect code base, but like you almost want to like bootstrap that repo with like, okay, we don't have any code yet. Like later when you build up your code, the LLM will just be referencing your own code to figure out like the style to do things in. But when you're just getting started, you don't have that. So it's a really good idea to take a different code base and be like, any like questions about like folder structure, etc., like follow this, and that can get you like started, kind of like a head start on getting like the LLM actually like operating well there. Another trick here is and this actually relates to Backpressure. If you're like recreating a feature that already exists, so let's say we're building a block explorer, right? A really good form of Backpressure here would be like a good first step would be I won't hit enter on this, but if we said like write playwright tests and make sure they work on Block Scout. So like a good first step if you were building your own Block Explorer is like write end-to-end tests against a working Block Explorer, right? Once those tests pass, you have pretty high confidence that you have like a good test suite. Now you can swap out that Block Explorer and build your own with this like really good Backpressure already built in. Anytime if you're like rewriting something, like let's say you're rewriting a library from like JavaScript to Rust, a good thing you can do is like be like, hey, get these rewrite these JavaScript tests in Rust, but have it test the JavaScript code and then swap out the implementation. Like things like this, like utilizing existing code bases like this is like extremely powerful. Do you try to remove test contexts that are unnecessary? I don't ever remove tests. So the way I kind of look at it, and this is some people feel differently, but the way I look at it is like the power of Backpressure on LLM is so high, and like the negative downside of like maybe a useless or duplicated test or something is like pretty low. It's just like the cost is pretty much the time it takes to execute it. So I'm so Backpressure based that like I'm producing so many tests. Like for example, my JJ Hub project has, I think we're almost at 100,000 tests already. So like me going through those, or even the LLM going through those and like deleting tests, I wouldn't feel very confident about. I kind of have a just like more tests is better. When it comes to LLMs, the more tests are annoying, and they would be annoying if I was like a human working on the code base. But for an LLM, it's like that Backpressure is so invaluable, and the LLMs don't really get slowed down much because they just produce code faster than we can review it. So I tend to just like keep all my tests around and just not worry about like figuring out which ones I should delete. All right, we have like a little bit of time left, so let me see if there's anything I should mention. I should show you Smithers really quick, actually, too. There's this review touch point that I should talk about, which is I mentioned earlier this like research, plan, implement flow. I think something I can say really quickly. I won't demo it, but like if you like review the plan, and you have like a pretty good gauge on like what the LLM is capable of, you will very often not have to review the code, and that's often usually desired. And what I mean by that is like it's a lot easier to review a markdown file that's kind of made for human consumption than it is to read the code at the end. So the way I think about validation is like the end validation. I want it to be mostly like tests and stuff that's giving me confidence, and then the plan in terms of like making sure that it's like doing the code in the style you want or doing or like touching the right things. Like it's a lot easier to review a plan there, and given like reviewing often becomes the bottleneck. Yeah, that's usually a good idea. By the way, it came back here. It didn't come back with what I wanted. There's actually like a Microsoft TUI testing framework that I would hope it would find, but this is a good one too, VHS.
Could I ask a quick question about Smithers, or I guess prompt you to show off like a first thing on Smithers? I know that it's like React based and is kind of different than like other Ralph based harnesses for that reason, and I don't really know how to think about that. I don't think it really means that you're reviewing a lot of React code or doing React development. So how did that come about?
Yeah, I can definitely show off Smithers.
Also, I don't know if the screen share stopped, but I stopped seeing typing.
Oh crap! Yeah, I know how I broke that. I think. Hold on, let me reshare. This one should be more robust to not breaking. Yeah, so Smithers is an orchestration framework. And what orchestration means is just a way to have like multiple agents, multiple steps, and like long running agents happen. I'm showing you code here, but just to be clear, like the point of Smithers, if you're writing this code or even thinking about this code, you're already doing it wrong. This is like what your LLM is supposed to write the code. You're supposed to just tell the LLM what you want. The LLM writes the code. But basically, like you have outputs. So you declare like what outputs you want the LLM to produce with Zod. And then you can create agents. Here I'm using like the Gemini CLI with my subscription to create an agent. You can give like an agent assistant prompt. And then the actual Smithers workflow, the way that works, and sorry about the TypeScript types. You basically just export this default Smithers, and the way Smithers works is it's XML based. So like you create like a plan that's declarative based on XML. So like sequence just means like do these things in sequence. This could be parallel, and it would do things in parallel. And then you have tasks, and these tasks can be agentic tasks. So here I gave it an agent, but this could also just be like run npm test, could be a task too. It doesn't have to be an agent. And then you tell it what the output should be. So this will like retry. If the agent gives you like the wrong output, it will retry. And then you can give it a prompt in here. It supports MDX, if you know what MDX is. So you can write in the MDX file, which will basically produce like a markdown file that takes React props. But basically, like, yeah, it will like execute these tasks in order. And what people really like is just this syntax is just like really easy to understand. And then what makes it extra powerful is it's very much it's kind of like inspired by Terraform, where you like create a plan, but you don't like create the imperative, like how you do it. In the same way here, like you're creating a plan, and like how this gets executed and how the retries happen and all that stuff is abstracted from you. But what's extra powerful is you can, if you have some state, so like maybe if it's like output, maybe let's just say we have like is error, so const is error equals true. So that maybe this would like be outputted from a different task, or let's say like CI failed. You can have like some reactive code in here that's like CI failed. If CI failed, then like human, and it will just be like, hey, if CI failed or something failed, like go ahead and just like notify a human and stop right away. Like this is like, I don't expect this to run, but like basically like what Smithers allows you to do is allows you to, one, create this like really easy to read and audit plan that can be pretty advanced, and the LLM will kind of one-shot it because it's React. It's good at React, but then you also, because it's React, you have the ability to, as the plan is running, change the plan. And it goes beyond that. You can actually even, the way you're supposed to use Smithers, if you read the docs, is you're supposed to actually have an LLM run Smithers, and then it will be like self-healing. And what that means is if there's like a bug in the script somewhere, the LLM will be smart enough to be like, oh, stop it, restart it. Everything in Smithers is being saved to SQLite. So this context under the hood is just reading from SQLite. So you can like stop and restart Smithers workflows, and they're 100% durable in that way. You can change the plan as they run. And yeah, you can build like pretty advanced things. So I guess like because I think we're at time. So I think like the last thing I'll say is like everything that we talked about today, you can actually encode into a Smithers workflow. So if I go to what did I call it? XVI. Yeah. So if I go into here, for example, here I'm just vibe coding a Ethereum. This will be the last thing I'll show you. I'm vibe coding like an Ethereum execution client in here. The first thing you might notice is that there's like a million submodules of like every piece of context I could possibly find that is useful. Like every piece of Backpressure I could find that's useful, Hive, et cetera, et cetera, et cetera. And then there's like a Smithers. Where would that be? Yeah, there's going to be a Smithers. Oh, I actually have multiple in here. Nice. So I have the Smithers Slop Factory script, is what I called it. And you can see like here I automated a lot of stuff that I talked about. So the way this Smithers script, if we read it really quick, this is going to be like a general way I like get work done usually, is like it starts off by just updating a progress report. I'll use like Kimmy for that or something. It will like review the code base. Discover means like find linear tickets to make. And then here you can see it says like take all the unfinished tickets and put them into a thing I call ticket pipeline. And in the ticket pipeline, you'll see some of the things that I talked about, which is it's basically doing a research plan implement, which is what I talked about earlier, as being like the most common way people use an LLM. Here, it's the LLM itself doing it. But yeah, we'll like first research the ticket, find any useful information, then plan. We'll come up with a plan. It's like plan mode, but in Smithers, basically. And then this validation loop, talked about this, where it's basically just going to implement. It's going to like implement and then do a bunch of back pressure, like make sure the tests work, benchmark, specs, code review. It will have like 3 LLM. It will have like Gemini, Claude, and Codex all review. They all have to say looks good to me. So it's just like you can see like all the back pressure. This is pretty much everything I talked about, just kind of automated. And then at the end, it will create a report, and you'll see like one of the why Smithers, like the biggest thing, this is the last thing I'll say, and then I'll end. The why Smithers is like the bottleneck to using LLMs when you really push these things as hard as possible is like, you're just like, what the fuck is happening, right? Like, you're just like, there's just so much code being produced. The LLMs are just doing so much that like, you don't even know like what got done yesterday versus what I need to still work on and stuff. So there's like one of the powers of Smithers is that you get this incredible observability where you can like create reports easily. All this stuff is stored in SQLite. So if I won't show that just for the sake of time, but if I went into Claude and I started asking it questions about like, what did I do yesterday? It would be able to query SQLite, find every single workflow that ran, every single chat log that happened, every single tool call that happened, like any information it wanted, I could like ask it about. And I'll send in the chat afterwards. And then someone actually built like a UI too, where there's this really cool UI where you can like visualize Smithers running. And that visibility just allows you to like kind of have these like long running, like multi-day Ralph loops where you can like check in every once in a while, make sure it's going well, maybe steer it a little bit. And that, yeah, that's kind of like the value people kind of get out of Smithers, is that it just makes like doing everything I talked about like a lot easier. And then, yeah, on there, if there's any questions, I can answer questions too. Someone's still setting up. I can stall for George if you want me to.
He had 10 minutes. I'm sure he's ready.
George,
Okay.
are you ready? I'm not sure if the thumbs not up is from you.
You can take some time for QA, please.
Oh, okay. If we wanna stall, we can. I love watching other people's kind of vibe coding methodologies. It's really, really interesting. Do we have any questions halfway through the session now? Next up, we have George, who's going to be demoing a DIY fork of OpenAI's Symphony agent. But in the meantime, while we stall,
yeah, Fakri, what's the biggest project that you've done using Smithers all the way through? Like, have you used Smithers extensively through your fast EVM implementation?
So I would say that was I didn't use Smithers for that, but that was like kind of the project where I kind of like learned what Smithers should look like. Does that make sense?
Yeah.
Like that project was kind of where like I hacked together. It'd be cool actually if I should actually do a talk sometime where I show that hack together flow, because that hack together flow almost really demonstrates like kind of how context engineering works, where like I would hack together a flow that just purely involved writing files to the file system, right? Just like writing tons of markdown files. And I think that's how I figured out like how Smithers should work. Because before then I didn't really like all these like context engineering things were kind of vague ideas and not like concrete in the same way they are now. I think like everybody was still trying to figure stuff out back then. I think the biggest project is just JJ Hub, which I'm building right now. I can link to that if anyone wants to sign up. But I basically JJ Hub, like the first POC of it, I built with Smithers, and it was basically just a week to build like a working feature complete, like almost like GitHub replacement. Cost a tons of tokens. So like my token spend right now is like kind of out of control right now, especially if you saw how much Backpressure I use with like reviewing and stuff. I currently have like seven subscriptions that I'm burning through, and I'm still like hitting overages. So that's brutal. But like it's almost like Smith, like some of the things I showed you, like if you just try it out, especially like the LLM reviewing itself and then that research plan implement, you'll just be shocked at like how high quality the code that comes out is compared to what you might be used to when you're vibe coding. If you like truly have it's like one of those things like you have to experience it to believe me, but it's like it is possible to get an LLM to write like slop that you're like happy to ship into production, believe it or not. It's just like takes a lot of effort. Yeah, the thing I showed to where I was building an execution client, I don't have enough tokens to have that going right now, but like that's also like a pretty big project, I would say. But it's kind of easy mode in the sense of like an execution client is like extremely well specified and has so much like so many tests you can use and like 7 what I don't know how many, just so much like reference code. Like I don't know how many clients there are. So it's kind of set up to be like one of it's similar to the C the when they built the C compiler, where it's it's one of the more impressive things that is actually not that difficult to do. Because you have so much like reference code and so many tests and stuff that you can use. Smithers itself, I guess I built Smithers with Smithers. So like the first thing, kind of like the first milestone. Same with JJ Hub. The fun thing about building like vibe coding tools is like the first milestone you want to reach is like dog fooding it. It's like how fast can I get Smithers being built with Smithers, so that like I'm like testing the product the whole time as I'm building it. I can definitely answer any more questions if George needs more time.
George, can you give us an update on rough timing?
I think I'm ready. Yeah.
Yeah. Okay. Should we get started on the third part of the session?
Okay. Cool. I just need to share my screen, right?
Yeah, please. Do you see the screen share button?
Let me check. Share window, I suppose. Oh, can you guys see it?
Yes. Yeah, we can see the full screen. If you're going to be in the terminal, could you zoom in a couple of times?
Of course. Let's see. Okay, so let's start. So like this is like essentially just a pour of the OpenAI Symphony things, and like the idea is actually like pretty straightforward. Like so you know you're kind of just like working above the abstractions, and you know you can have the abstraction as essentially a developer, an engineer, you know, working on the specific tickets yourself. And then like you of course, and that like interface will essentially be in like IDE, right? And but then like later, you know, like as you move things up, like when you're managing like a big projects, usually like you have like some kind of like task management, project management interfaces like linear, right? Something like you see here, right? I think like the interesting idea of Symphony here is essentially the assumption is that you know, once you set up your code base in a way that's like a convention driven and like strict enough, that like the current generation of coding models are actually already good enough to essentially act like independent engineers, to essentially just take the ticket from the linear board, right, and then just do its work completely autonomously, and you know, get the things done, get the PR up, and you can either choose to review the PRs or like even skip that part, just have the agent like YOLO merge it to main, right? It can do everything, including like plannings about specific execution of the tickets, and actual execution of the implementations, and also like end-to-end testings. If and the thing is I think they have a good demo video for a simple case. So I think like the cool thing here is that the instruction is actually high level enough. Like for example, they have like you know, like a lot of the details are actually not in the Elixir code. like it's actually in the like workflow files. So I think like there are some kind of default posture is you can think about more like state machine type of stuff, right? Like once what state it is in, like, and like what next state you should move it to. So that's not like too complicated, but like you can see some of these, right? Like some high level like principles. You're kind of like teaching a junior senior engineer. Right, start every task by opening track workpack comment and bring it up to date. Spend extra effort from planning and verification design before implementations. It's pretty high level instructions and not really anything that's like specific to any like tech stack and project. You can say those are like just good software engineering practices, right? But these are like doing a lot of heavy liftings. So I kind of like did some like some tests myself. Like if you move some of these, like the thing just doesn't work very well, right? Yeah, so I think like this is like pretty cool if you're like interested in like learning about essentially how a lot of those kind of prompt engineering things are working, and specific for OpenAI related models, because you really have to prompt it in a very specific way for you to get the behaviors you want, right? So yeah, this is like I think like about 300 lines. Yeah, some cool stuff like end-to-end verification, things like that. So a lot of details, and this, I guess this is kind of another question of how you like iterate the prompts to something like this, but they do have it ready for you, and this actually makes all the difference. So this is kind of like the workflow thing, and usually the way I do it is that it's just kind of like a big linear board, right? And like maybe you have like this is like a project I'm going through right now. It's just cutting down a lot of tech debt. Like one question you might have is like, how do you set up like a board like this? Like you might object that like, I'm not like product manager or tech lead, right? Like this is just not my habit of doing things, right? And like a lot of these are like actually pretty detailed, right? Like you can kind of get like a rough sense, context, scope, well, some context specific things, which file is supposed to work on, validation rules. Yeah, I didn't write any of these, to be honest. And the way I do it is actually just use a linear MCP. Right, the app is linear, right? It's a pretty common like project management type of stuff for software engineering in the industry. So you just set up a linear MCP. There are like instructions here, right? Set up like in whichever things you like, working most of them, right? And then like once you set those up, you can just like essentially chat with your Cloud Code, where's my terminal? Something blew up. Oh, right. Right. So I have like I have a specific thing. So I use a linear command line I built myself, but the linear MCP kind of works as well. So for example, let's say I'm in a middle. Oh, sorry, I can't zoom in here. Of course, you need to give them some instruction about which linear board you're working on. Right. So it's gonna take some time, so we're not gonna waste time here. So then like it's just gonna populate these tickets, like all these tickets are kind of like populated this way, right? And the idea is that like you have like a bunch of to-dos, right, set up here, and then like you just different one, and like you just like start the Symphony process here. Well, I was trying to fix some of the setup issues, but But like what it does is that it just have like you set the concurrency, right? You set the concurrency in actually the the YAML here of the workflow file. So like workflow is both instructions and the configurations, right? Project slug, which is the name of the Kanban board you're using. Pooling intervals. Agents, basically how many agents you're gonna have, right? Running concurrently. That totally depends on how you set up your project and how parallel they are, right? You can ask your agent to like, set up the task board in a way that maximize parallelism, stuff like that. You don't have to handle those yourself as well. And max turn is basically, well, it's kind of running something called a RAF loop, which is just like just a while loop with like a max iteration counts, right? You just ask the agent to like keep doing it, like give it one try, probably like resolve some things. And this is like some like of the current model capability limit that you're kind of like just patching with like external scaffoldings, right? Like you can give it like a huge task board, right? Something like this, right? This is not one of the biggest one, probably. Right, this is probably yeah. So it's just a medium-sized one. So like these are like essentially written by the Symphony agent when it's starting like the task and the running through things. So it's going to plan, write out acceptance criteria, stuff like that, right? And the reason why you need this thing here is because the model here is still not like good enough at just take a big plan and just keep executing and don't stop until the whole thing is through. And part of it is because like context issues, like usually like your context window is not big enough to grind through the entire plan. And like they're still working on like long running agents natively inside the model, so the model behavior is still not there. But what this iteration is doing is like every time it gets one run through and like check some boxes off. So this is kind of the persistent state or memory of the agent, right? And every time like before, if it has not reached the maximum iterations, you will just keep going, and every time it just load this whole work pad, and so this gives you a sense of the current state, right? And the agent say, oh, I'll continue from here, keep working until you exhaust the max number of iterations or the whole thing is done, right? Like you can get, no, this is probably some manual ones. Let's see. Yeah. So keep running, and you get done the whole thing. Keep adding notes, and at last step, you kind of ready for human merge review. You move to like another queue that's for review, and then you can just see it there, and you just go to the PR, right, and you review it there. Yeah, so that's kind of like the entire workflow. And let's see if the thing is actually working now. Oh, yeah. So this is like, yeah. So, this is doing just, it's like project planning things where it's gonna like add stuff, to linear issues, whatever. So this is just doing its own job, right? And the idea is that you don't have to do all this project management stuff yourself. And well, let's see if I have fixed the thing. Let's see if it actually runs now. Damn it. Something is... Okay, I think I broke something here this morning, but I can show the demo videos. It's close enough. Yeah, so like that dashboard is just like something like you see it like, and it's just running inside, right? And you can see the events, how many are running, like backup queues, like just something like this, right? You can see how fast you are burning your tokens. It can get pretty crazy sometimes. And then like basically like what you're going through is Yeah, so he's like just giving a demo of like to-do app here. Right, so you add to-dos, but of course you don't have to do it manually. And then like, okay, agent will actually like in real time move them to like in progress. You can see, so you just look at your linear board to see what's going on and like see, yeah. So like, and you'll gradually just go through the plan, click items, and it's done. And you will actually like for some of the front-end related stuff, right? It actually will record a video for you and append it there. You can just review it here to see how it actually looks like. Just like when you're reviewing the work of the engineer. Yeah. Yeah, so you're basically like kind of like working like more like a tech lead, like an engineering manager than an actual engineers. And like the agents are just like getting a place where it's good enough to do all the work like a senior engineer is supposed to do. And then you can just stay at a higher abstraction level. Yeah. That's it. Yeah. I'll answer questions. I can continue to debug my things, so hopefully I can get the live run. But that's most of the ideas.
Thank you, George. That's okay. The demo gods weren't in your favor today, but they've actually been quite good up until now. So you just got the bad end of that stick. Thank you for coming and delivering. Do we have any questions between now and our final session?
I'll ask a little bit. I guess my first thing is like you're using linear, you're kind of using its state as like an alternative to the SQLite DB that fuckery uses. The UI is great, but you're also like posting the issues, it seems like, from Claude Code. So you're only using the UI some of the time. I'm just trying to think through what like effects that's having on your overall development experience. Like, does the fact that it's linear kind of shape what you write in a way that makes it work out better than it would have if you just didn't use linear at all?
Oh, you can use stuff like the beads thing. That's basically like I just realized I didn't open my video. You can do that as well. That's just pure command line, more token efficient. It doesn't have the pretty UI. You monitor live, see things moving. From to do to review, you clicking and they have smooth. Like renderings give you to watch, right? Because like it's essentially at the abstraction level you want, right? When you're like it used to be the tool for like tech lead to see what my engineers are doing, right? And right now like your engineers are just the agents, right? So I think like the design is kind of like it's exactly designed for that purpose. And for me, I guess like I'm used to using that, and now it just instead of like interacting with real engineers, I'm just working with agents. Yeah.
What's the biggest project that you've done using this workflow mostly?
Oh man, yeah, it's a big tech debt refactor. We were building something on top of a pretty designer coded open source library that's also vibe coded. So things actually work and things look pretty. I didn't like look too deep into the code base until we said, oh, we're gonna build on top of it. And like it turned out to be a disaster, and I have to like cut down like probably like tens of thousands of lines, and like it's nearly impossible to fight like clanker generated slop without using your clanker army. So I think like that's like a big project I'm working on right
Did
now.
it already have a lot of tests or detailed design documents to push against, or like did you essentially have to make those?
I have to make those as well. Yeah, I have to make those as well. Yeah. I think like there is also like an interesting I kind of show it a lot. A blog post I can share in the chat link. I think like one thing very specific about this is that you really need to get your code base in a good shape or be very explicit about what you want, with the agent up front. Like, and it's even very funny. Like some conclusions like people reach is that you have to use those like super cumbersome like enterprise patterns, you know. And the idea is that if you think about it, the enterprise patterns are invented to kind of coordinate a large group, you know, of engineers that are probably not super talented, and you know, that you want to isolate their work so that they don't like interrupt each other, and like they like you want to make it from like no fuck up to can't fuck up, right? So like enterprise patterns uh, are exactly that. And like I think OpenAI's finding is that like if you just lock down your code base and make it like exactly like that, and you like then the like enforce all these kind of linting rules, pre-commits, and then like agent can't fuck up, right? Like it literally can't commit, so you just have to keep molding the code into the shape you want in the code base. Yeah, so I think like because I think like it's something like the way like the models are like fine-tuned, like they're not super disagreeable, you know, like I think like they fine tune for the EQ a little bit too much. Like it's not autist enough, you know. Um, like you know, the correct behavior a lot of times when the agent like comes to your code base, right? And they talk about it as like capability overhand, right? The model capability is there, but it's just the behavior is not nudged correctly, right? Because a lot of times, like in your code base, and the model have good like code base quality understanding. Like a lot of times, it's teaching me stuff, right? But it's too agreeable, right? It's not saying, man, like your code base is piece of shit, I need to rewrite this whole thing, right? Like it's not gonna proactively say any of that. Like so you really have to essentially, you know, explicitly, you know, ask for that kind of behavior, right? Because if you don't ask for it, it's just gonna like be, you know, agreeable employee, you know, the typical, you know, employee that quickly, you know, rise up the ranks and don't do anything and make the code base worse, right? That's a default personality actually. It will just keep like piling on shit, you know, on your you know already like 10 feet high, you know, shit, you know, code base, and not trying to make any like radical architectural change. So I think like that's probably like high level the biggest lesson for me.
If we're ready, we can move on to our final part of the session because I see we have Jazzy in on stage already for our last session, which is on demoing an agent's first baseline hackathon participation, which is fun. So Jazzy, welcome. Do you want to share your screen and we can get started? We cannot hear you if we're supposed to be able. Oh, there you are, there you are, audio. Okay. We can hear some traffic from somewhere, so that might be from you, but we can't hear you.
Okay, what about now?
Now we can hear you.
Wonderful, wonderful. Okay, hi everybody. My name is Jazir. I actually set this to be more of an informational talk. That said, I can maybe try and share a little bit of code or things that are running. I feel like the way I set this up might be very well received, but if anyone has any concerns, we can always like switch things up a bit. So I'm gonna start. Can you guys see my screen?
Yeah, looks good.
I do get this sometimes. I do tend to just share this view of the screens rather than like going full screen on these kinds of like decks. So I can like switch in and out of stuff. Anyways, so what I decided to create this talk on is recursion, agent swarms, and the future of productivity. It kind of captures some of the way I approach these kinds of problems, and also there's like a piece of feedback that I got from somebody else regarding like, this agent swarm that I was considering doing for this project, which I think is how I got invited to be a speaker. So it's sort of like the thesis behind some of the productivity tools. Just for context, I went to Yale. I worked on 2 large crypto projects as like a early sort of team member / founder. And I'm also now just basically doing private work. One project you might have heard of that's like somewhat public that kind of connected me to some of the Flashbots people is Eliza. But usually I'm pretty anon, frankly, at this point. So you like this is me like kind of coming a bit out and being public, but most of my name is not on stuff. It's not on Eliza. I did that under a pseudonym as well. Anyways, so the purpose of this talk is why recursion is important for productivity, grounded in the recursive self-improvement concept, which you might have heard of. And then secondly, it's why agent swarms are good for recursive self-improvement. And then my productivity stack. So for recursion, right, you probably are familiar with this idea. You have some program that you want to improve. You just try a few different options, and then eventually you like improve that based on some kind of outcome score that you're looking for. And then you can improve the improver. You can improve the improver, right? I think that this has gotten super huge with auto researcher, this pattern. So it's helpful for me to like take a minute to just digest. If you haven't, kind of like seen this, it's all over the AI space. The idea is that research is now done entirely in the domain of autonomous swarms of agents running across compute clusters, you're doing something like recursive improvement. Maybe not self-improvement per se. It's not always optimizing the auto research code itself, but it is definitely like iterative optimization. And you can see, you can point this at a few different targets. One person's pointed it at quantitative finance and gotten like really great financial algorithms out of it. One person has actually used this for skills. So instead of just like pure like foundation models or neural nets, this person's done it on like the concept of a skill, a piece of text. So they have a skill, they run the skill, they observe what happened, and then they fix whatever took place. If you take a look at the text here, it's like this thing can work, a skill can work, but then start failing when the code base changes, or if a model like changes, or if the tasks shift over time. Which kind of brings me to the big issue with recursive self-improvement, that you don't necessarily know what you're changing, or you're always changing things inside of an environment. And so that's like the problem, right? You have to define the self. Are you talking for a recursive self-improvement? Are you trying to optimize a particular run? Are you trying to optimize the source code? Are you trying to optimize a deployment? Are you trying to optimize like your entire social structure or your company or whatever? Are you trying to optimize a physical machine? This is really challenging. And I would say as a corollary, I have had all sorts of insights around how to resolve these problems that I found in real life. You end up with this sort of Tower of Babel issue where some people understand one thing you're saying, some people understand a different thing you're saying. And so unless you kind of become the whole universe, it's actually very hard to build recursive self-improvement from a pure product or tech perspective, because of these social issues that anyone who's like worked on advanced AI systems might appreciate as well. So which is why we have such a plurality of approaches to kind of like hit the nail on the head before we go into multi-agents as a solution. There's some really great research on self-referential systems that I've taken a look at. This quote kind of helps to explain that a system can't really create a complete, consistent, non-lossy, internal, and computable model of its total current self engaged in the act of modeling. There's always some kind of a cut or incompleteness, which is where you get errors, essentially, right? The question is just, what are you going to like not model correctly? There's more research here if you want to take a look at these papers. So what I want to do is solve self-reference through a multi-agent coordination section. So instead of one agent or one entity, one model trying to resolve itself, trying to recurse on itself, you have multiple agents that communicate with each other. The idea here is that each agent represents a different part of the decision space or the design space, the environment of some kind. And they don't necessarily like recurse on themselves as they communicate with each other. And that sort of brings you to like a lot of, wait, can you guys see my screen?
We can
Yeah,
see
it's
your
still looking good.
slides.
You can or you cannot?
We can see your slides.
You see my screen. Okay, perfect. I saw like based on my UI, I was worried. Anyways, so the reason this is interesting is that you turn like self-understanding into a communication problem. It doesn't entirely solve the issue, but it like partially solves it in the sense that some agent owns a particular domain. I have a few notes here on like why that's important and like how this solves the problem I'm trying to address. They don't entirely self-reference, but they do coordinate. Happy to dig into this in more detail. And I took a quote from Carl Friston and a bunch of other authors in this paper called Designing Ecosystems of Intelligence from First Principles. Carl is a famous neuroscientist. He works a lot on active inference, if you've heard of that. Which is very common for pure like neuroscience, but also for like pure intelligence. And so the idea is like observation of nature suggests that simpler and more complex forms of intelligence are always related compositionally. So the idea is like instead of one intelligent entity, whatever it happens to be, you're usually looking at subcomponents of things that are like interstitched. The idea is that there's a communal or collective aspect of intelligence, to the point that etymologically intelligence means inter, right, between, and legere, which means choosing to read. So intelligence is very correlated with intelligibility, and the more you connect to like other agents, the better you become at being intelligent yourself. So that's all to kind of point out like two multi-agentic approaches. I think there's internal kind of decomposition. So LangGraph or LangChain, multiple Claude Code instances, Crew and AutoGen or Cursor subagents. I use a lot of Cursor myself, where you take what you're doing and you split it up a little bit. And then you have a bunch of agents and models approaching the same problem from different aspects. This, I think people are relatively familiar with. I can talk a little bit about my stack. What I'm trying to branch out more into is external agents, so connecting to other people's work. This is something I'm seriously considering being my own commitment to this project. It's just this hackathon. I will have to see. But Hermes from James, who's a judge, actually is something like that, shared channel infrastructure where the agents can subscribe to knowledge streams. There's also something from CoiNet, which is from Block Science, which I think some people here might be familiar with, where you essentially take heterogeneous nodes to share and propagate these knowledge objects. Open Agents is like what Moltbook is, but I think more serious and yet not very popular. And Moltbook, if you haven't heard of it, they're actually just acquired by Facebook. The worst implementation in terms of like actual intelligent information kind of coming through, but really good adoption. And so they got bought by Facebook, and essentially, long story short, is they allow your open clause to talk to each other. I actually built like a better version of this that I might like polish either for the hackathon or for other things. There's also auto research at home, where you have a swarm of agents using auto research, but all on like the same project. And I want to say actually it was at a hackathon with the auto research at home guys recently, and they only had like 70 agents in their network at the time. This was like a day or two ago. So we're seeing something where, and Hermes only has a small number of people using it as well. Same thing for all of these except Moltbook. I really do think that a lot of people are trying to get their agents into swarms with other people. And there's a challenge of like, how do you think about, like, how does my work connect to your work? I want to talk a little bit about that. What I would say is one thing that's, I think, a little bit different from me versus everybody else is I'm, at least from what I've seen, from the limited parts I've seen this hackathon. So I'm like actually like, a CEO with like other people on the team and coordinating a lot in group contexts. And so I see a little bit more of this merger between the internal and the external. I have this quote at the upper left that, some guy used to manage 10 engineers, but now they manage 10 engineers that each have 10 agents. So I'm a manager of a manager. I have to build a pipeline to keep up. What I say this to say that I think there is a stage of building a multi-agentic system where you have to include other people that is more common in like executive spaces. I managed at one point like 50 people. And so I'm all like, that kind of brings you to the lower right corner, which is I think that people may not realize how much product managers or directors or CEOs have been prompt engineering for a while. They're just sending the stuff to people. So like I just want to point out, like, I really see internal and external as like somewhat connected for reasons that are becoming more obvious to people who are traditionally ICs. So then my personal stack, if we have time, happy to like talk a bit about it more beyond these slides, but I code, I communicate, and then there's operations. On the operations side, I have this thing called Grip, which is kind of like OpenClaw, which you might have seen. Paperclip, if you haven't seen it, here is a really popular application that lets you run what they call zero human companies. It's got like 26,000 stars, so relatively popular. I've taken notes from all these. Grip is closed source and it's constantly being changed, right? I'm scared for if I try to do a demo because I don't I change this stuff all the time, and you ask people to do stuff all the time outside of these systems. But OpenClaw, I'm sure you've seen. Paperclip, you can imagine it has org charts, it has goals, it has budgets, it coordinates these agents, and then Mac Mini agents. So I just recently set my computer up. I actually have a screen, so it's not really a Mac Mini. It's got a UI, but the idea is you can just control the entire system. So you've got a little like automatically running agent that does whatever it is you need to do, and is like connected to business functions with like Paperclip. So then there's this other thing I've got called CCE, which is kind of like Gary's G stack. I may not need to really explain this to this group, but if you look at this guy, so this is from the head of Y Combinator, who's got his own very popular repo, 16,000 stars. It's got the CEO, the Eng manager, release manager. I think he says he's pushing like 100 pull requests or commit today or something just absurd. So again, everybody has a version of this, I think, in our group. I have mine. There's also, maybe you've seen Gemtown, I think they call it, or yeah, I think it's Gemtown or Gastown, right? Yeah, so this is another very popular one where you're like, coordinating multiple Claude Code instances. You've probably seen, I know Beads actually came out of this. I think, or at least it was made very well known. So happy to dig into these more people want, but like this essentially can take an idea and then turn it into a like relatively well-structured project. In my kind of system, we've got a coding agent. You pointed out a GitHub issue. It orients, it plans, it executes, it reconciles, it sends you a pull request. Right now, I'm actually updating the system so that it doesn't work on individual feature tickets, but rather epics. I think I'm a little bit more maybe granular. I come from a technical product background than some guys who are just like more just pure eng or especially research style. But the idea is like we want things that we can ship, and if I can't ship it with my system, I would ask a dev to take a review or what have you. Runs 24/7, or at least it can run things concurrently. One thing I'm really big on, I know I saw George talking about concurrency. What we do is we just create Git work trees. The orienter decides sort of at runtime, for each loop. Imagine that an epic will take like 10 tickets. The orienter will kick off one loop, and it'll say maybe 2 or 3 tickets can be run in parallel, and then we merge, and then we do the second loop, and we do maybe another 2 or 3 tickets, and so on. I'm really into merging and like testing and just making sure that whatever we produce is shippable. There's also runs. So this is actually all built on the LangChain, LangGraph stack. They also have something called Deep Agents, which is really great for this. So they have really good work on tracing. So you can look at your runs and then see based on the traces in what they call Langsmith, which is their like version of Sentry or a logging tool. You can see what happened. You can actually have the AI analyze where it may have made a bad decision, and then you can make modifications. That reflection, that recursion piece is really important. And yeah, so the self-optimization bit at the end. So you can actually, I get some improvement tickets on my system, which I'm really into recursive self-improvement. The last piece is communication. So this I've seen from quite a few people. A lot of people want this. I'm kind of sort of working on something. I would say it's the general gist is like, you ideally would want a fork of your social network, right? I should be able to see Rebecca and George and Andrew bots and be able to talk to them on an ongoing basis. And I actually did build something like this for a particular reason, but I haven't really I haven't really tried to get much adoption on it. I think we'll see how this kind of goes over time. The idea is the agents have identities and registries. I also have Courier. I think if there's one like takeaway from this, you might appreciate that my code bases can also talk to each other, like separate from me. So if one code base needs something from another code base, I try to run them all in these like separate environments, and they have at least enough awareness to like send files, send skills, these sorts of things, separate from Sentinel, which is more like communicating with team members on Slack or like email or whatever, and like a lot of stuff's moving to Git. In terms of what I think it takes to make this work, I had someone actually create a multi-hour like qualitative interview. There's a great paper you might have seen called Generative Agents. What it essentially says is they simulate the attitudes and behaviors of over 1,000 real people, and they apply LLMs to qualitative interviews about their lives. And the generative agents replicate participant responses on a general social survey 85% as accurately as the participants, only 2 weeks later. This is a social problem. I think the alternative that you might want to see, I won't try to look this up because I think it'll take some time, is Facebook, and I think Atlassian and Block and maybe a few other big companies are letting go of people en masse. And what we're hearing is before they do that, they ask a substantial number of people to describe how they work in great detail. So this multi-hour interview is really, really important. And if you get past a certain threshold, you can really track how somebody actually thinks, or at least how they operate in a productivity environment. I think you can do both. And one of my concerns has been separating the social implications from the like maybe corporate or productivity implications. But this is sort of another thing that I think is really critical. So I think you probably can imagine how all of this would lead to emergent coordination, behavior that looks organized and coordinated, but arises from local recursion, self-reference, and intersubjectivity rather than a single plan. And and the last thing that I wanted to share, right, this is like a good segue, I think, is when I am looking at hackathon projects here, I'm just gonna share a different part of my screen right now. So you guys can see my personal project management repo. One cool thing you might notice is I have a work log document for every day. It's not exactly every day, but I try to track what I've been up to. And the reason I'm sharing this is that it contains, I can recursively self-improve my life, right? If I know what I'm doing and the AI knows what I'm doing, then it can just give me certain kinds of feedback. In any case, for these hackathon papers and code organization chat, what I ended up doing here is, oh boy, let's see here. If I go to hackathon here, and then I look at something like conditional recall, right? So I have the paper that the author created, and I have some code that he created as well. I also have this thing called a stakeholder analysis. So I think we were talking before about these corporate environments. I use this thing called ISO IEEE 42010, which is a very, very corporate document for how you create architecture descriptions. And just to give you a piece of like how useful this is, the thing will identify entities of interest. So what exactly are we trying to address? Environments. So like where exactly are we addressing things between financial markets and the hardware and the agent infrastructure and so on. And then it identifies stakeholders. So I am already looking at these problems as like, sets of things like many people will need to address, many different kinds of people. And then I like think through, what do all of these groups want based on their perspectives, and then concerns that each of them might have. And so all of this kind of feeds into viewpoints, and then ultimately like architectural tensions. This is like a really good input to how you might build, like what you're building for, essentially. I have some other stuff. I think the only other thing I saw that I wanted to respond to is that I had a lot of stuff around not just testing, but like logging, performance, benchmarking, internationalization, even like interoperability standards that are all stakeholder based, where you try to reflect that a group of people might want a particular thing and how they interact with another group of people. So I think I've said a lot. We might have started late, but I also think I took up most of the time from my time zone onward. It was 10:30. I think it's 1:30 for East Coast people. So I want to stop, see if anybody has any comments or questions.
I'm not seeing anyone in the chat with questions, but I have a couple. I mean,
so I'm actually not able to hear you, Andrew.
I think Andrew might have frozen. I was wondering if it was just for me.
I do see some stuff in the chat. Yeah, Andrew's frozen for me as well. I see like, are agents more defined by their model or their context? Is interacting with context somehow more than just one model with larger context? The answer is definitely yes. There is a paper on this. The agents are stochastic, right? So if you just use more than one model with the same context, but it's the same type of model, like you'll still get different answers. I think it's model, context, and also harness, right? That's what I would say to Andrew's comment there. Yeah, and then George is saying like multi-agents think a lot about context. Is a swarm basically modeling and stealing from other agents? Are they psychopath agents in the swarm? I don't know. It seems like George and Andrew were just like addressing their own questions. And then it sucks that Andrew's not available, I think.
Yes, I have just been told that his laptop has died. So I don't think he's going to be able to join us in the next couple of minutes, presuming it takes longer for a laptop to reboot once put on charge.
I mean, I'll address the one thing I think he said in the chat that was of interest, but then we might just have to call it there. So continuous self-improvement is great, but how do you avoid drift? I think that the comment that his other comment that the founder CEO has to be delusional to be effective. I think he means like, founder optimism, essentially. I would say, as a CEO founder type person myself, I think that agency is not evenly distributed. And if you have high agency, you may not be able to relate to low agency, and also it's very contextual. Bottom line is, I don't use this system automatically, right? If it was running perfectly, then I would have AGI or ASI. I'm in the middle of it, and other humans are in the middle of it. And the kind of point is that you get wider loops. You don't get full autonomy from this. And also that you want every single person's agency to be like effective in their domain. The agents extend them. I think the agent's CEO is only contextually useful, right? It's good at some things. But you have to give it a lot of guidance. So I don't think the agent CEO is delusional or not delusional. I think it's like limited in scope based on what you instruct it to do.
I think based on what Andrew's messaged me on Telegram, his questions were the ones that are in the chat anyway. So the kind of discussion as well between him and George. So thank you for covering that. And actually, we're perfectly on time for the end of the session. So thank you to all four of our speakers who came in and delivered a short demo workshop. Hopefully our hackers here were, well, hopefully already building, but working hard and potentially using a lot of the things that they've seen today to improve their methodology when it comes to vibe coding and using AI tools within their workflows. Hopefully you've learned lots. And if you do have any questions or further comments after this, or kind of a discussion that you want to have, then head over to Discord to continue that. I'm sure it's kind of a hot topic.